So as always, we start by reading this information, compare it to the diagram, check to see if there's anything additional given. From that information, we could just clarify that AC is 6 centimetres to make sure we don't get that confused with AD later on. And then our first part is to calculate the length of arc BC. So we start by the formula, arc length equals r theta. So that is just 6 times 0.95, 5.7 centimetres. Part B, also straightforward. Sector area is a half r squared theta. So plug in the values to get 17.1 centimetres squared. Read the next information carefully, check it against the diagram. And for part C, finding this length AD, let's call it X, and call that one X. There are several different things you could do here. You could use sine rule or cosine rule, or possibly something else, I don't know. Sine rule or cosine rule. Start by labelling what we know. So this is an isosceles triangle, so we could also put 0.95 radians there. We know that the angles in a triangle add up to 180 degrees, or pi radians. So add those together, take them away from pi, would give us 1.24 radians for that angle. I'll do two methods for part C, sine rule or cosine rule. Okay, so if we start off with sine rule, we get the side x over sine of the opposite angle is equal to 6 over sine of the opposite angle, and then we can solve that. As always, make sure your calculator is in radians while we're working in radians here. And we get that answer. So get that answer in radians, and a few extra decimal places for accuracy, and then to the accuracy that they want us to show. Okay, sine rule is probably the most efficient. If we were to use cosine rule, it would look like this. And I've used this version where I'm using cos of 0.95 rather than 1.24 because 1.24 was a rounded value. We can then solve that equation. And so we get the same answer here, and rounded to 3 significant figures. Okay, part D, perimeter of R. So looking at the perimeter of R, we have already worked out arc length BC. So that one there we know is 5.7. We have just worked out the value of X. We've worked that one out here. And DC must be 6 minus X. I've still got X on my calculator from the previous part of the question. So 6 minus my answer gives me this 0.84255. Adding those up. And actually I realise if I write it like this, 5.7 plus X plus 6 minus X, I can see those X's disappear, and then I've got an exact answer without any rounded figures. So 11.7 centimetres exactly. For part E, I just need sector area minus area of the triangle. So just using both my formulae for those. And actually for sector area, we worked that out in part B. So area of triangle ABD. So we've got our sector area and our area of the triangle. So looking at the shaded area, just subtract triangle from the sector for our answer, giving us 4.5 centimetres squared to 2 significant figures.